Okay, so we will start with the new topic today, which is again module 4. And so this is about the principles of AI ethics or principles of AI ethics. So while we already spoke about a couple of theories on AI ethics, right from consequentialism to deontology and virtues, but then there are some core principles of AI ethics, and Karp defines 5 principles. We'll talk about them one by one, and these principles, they are like general principles. They apply to AI in this context, but they can also apply to a couple of other things. So the first principle is called as the principle of non-maleficence, which is a very basic and fundamental principle, which says that whatever you do, you should not harm others, or don't harm anyone. Okay, so it's a very high level principle, and I think we tell this to everybody, kids, etc., that whatever action you take, you should be compassionate, you should make sure that you should not harm anybody. But having said that, it may not be always possible that whatever you do may not harm anybody. For example, in case of, say, medicine, when you do some kind of a drug discovery or any other kind of medication or discovery, it is possible that you may be able to benefit 95% of people or even 99% of people, and for the remaining 1% there can be some consequences. The consequences can be some kind of a reaction to the drug, etc., etc. So in those cases, we may not have the principle of non-maleficence applied universally or in all circumstances, but we need to, there is an appropriate consortium of people who will decide how universally you want to apply this principle. But that's the first principle, which says that whatever action you take, you should try to not harm anyone. Okay, so the second principle is called beneficence, which takes the principle of not harming anybody one level above, and it says that whatever you do, you act for the benefit of mankind, or benefit of people, or benefit of others. Okay, so this actually means that your actions should not just be business decisions which are good for making money, and it is not helping the humanity to become to do or some of our day-to-day operations better, or make it a better place. So that's the second principle. And if you look at a lot of, so there is no silver bullet that, or you cannot solve all the world problems, whether it is AI or any other technology for that matter. There are a lot of work that is happening these days, and most of the work that I do as a part of my research, etc., which falls under the bracket of AI for social good. Okay, so all of these AI activities don't have a lot of commercial benefit. For example, if you want to work for communities who are remotely located, or if you want to work on some of the languages in India, languages abroad, which are spoken by, say, tribals, or languages that are spoken by very small group of people, so there is no benefit for the biggies like your Microsoft and Google to create NLP toolkits for these kinds of languages. But unless you don't enable these people, these underprivileged people, to come on the digital radar, you cannot really make a statement that we are doing a great progress, or this is digital India, or everybody's on the digital platform. So beneficence says that your actions should help for the benefit of others. Okay, the third principle talks about it's called the principle of justice. So what does justice mean? That it's like, it's a general knowledge thing, that justice means that it has to give you some kind of a fairness. So you have to be fair with people. It needs to have some kind of equality, and it also needs to be impartial. Okay, so those are, and maybe it also needs to be proportional. Okay, so yeah, and it needs to be impartial. So okay, those are the kind of the principles of justice that needs to be applied. And then, based on the justice can also be further classified into smaller categories, which is like there can be a procedural justice. So procedural justice, and this is from the GARP reading itself, they have classified justice into smaller categories. So procedural justice means that there needs to be fairness in your operations. Okay, and it means that, let's suppose, if not just related to AI but in general also, you would have seen that if there are poor people who cannot afford advocates, etc., and if there is some kind of a legal proceeding they have to go through, the government provides them some kind of a free advocates from the government side, so that they are heard, they are not ignored. So the procedural justice is applied there. The another justice is called as distributive justice. And this means this distributed justice means that there needs to be equal allocation of resources. Okay, so it should not happen that only a few who are affluent in the society gets everything, and people who are not that privileged, as I was talking about tribals and people in remote communities who are not so well off, or who are not on the digital radar, they get ignored. So that there needs to be a distributive justice also. Then the third one is called as restorative justice. So what happens in society, there have been times that there are people who were not treated so well, and not just in India, it happens everywhere. Somewhere it was about blacks in India, probably it was about some communities because of caste, creed, or financial disparity. There are some people who were not treated well, so we need to put them at par. And then all these policies like your reservation, etc., they try to do this restorative justice. So what are you trying to do? You are trying to reconcile victims. So victims can be any kind of victims, social victims, or financial victims, or anything for that matter. So that's called as the restorative justice. Then there is interracial justice, which is very easy to understand. So there should not be any discrimination based on the race that you have, which is very, very important. And the last one is also called as social justice. So social justice means that all your human rights, or your right for data and data privacy, etc., that also needs to be at least the principle, the recipients or the people, they need to know where their data is going to be used, etc. So all of that is there. And so justice is a very, very complex topic, and we can talk more and more about it. But we just want to make sure that we understand justice from the perspective of AI ethics and from the perspective of GARP. So I don't want to get into too much of details. So justice is a complex topic, and there are a lot of other things that we can talk about, but I don't want to get into a lot of details. But then the GARP also talks about some approaches. So there are like I think four kinds of approaches, which is called as egalitarian, and then there is a utilitarian, then there is meritocracy, and then there is need based. So what it says is that there are a lot of times when you have a fixed set of resources and you have to distribute them across a large scale of population. So what happens in case of an egalitarian approach, you distribute resources equally among everybody. In case of, so this is the easiest one to implement, so all your resources get divided by n, and the resource per person is r bound. And in the utilitarian approach, what you see is that you find out who needs them more and who needs them less, and that's how you decide. And so there will be people who will get more than the average, and there will be people who will get less than the average. So utilitarian is that kind of an approach, but the utility is decided by probably the social circumstances or some of the other things. In case of meritocracy, it is on merit, so somebody who deserves more will get the resources, even if that person is privileged, underprivileged, doesn't matter. And on the need based, you don't make any thumb rule. However, you decide based on case to case basis on who deserves, who does not deserve. So there can be overlap between these kinds of approaches, but this is how the resource distribution happens in the justice perspective. Okay, so coming back to, I think we spoke about three things: non-beneficence, beneficence, and justice. The fourth principle of AI ethics is called as autonomy. So not a difficult thing to understand, but autonomy means that let people decide what is good or what is bad for them. Okay, so let people decide. You do not manipulate. So this is the principle. I don't know how much of this is true in today's world, when you see so much of digital content which is also kind of hyper personalized for your consumption, but that's a principle, that you let people decide, let people make the final decision of what is good or what is bad for them. And it also says that there are kids or there are old people who are not in a kind of a mental state to decide what is good or what is bad for them, or there can be other medical problems with some people. For them, you can have a authorized person who can take decisions on their behalf, okay, which is decisions on their behalf, and this person can make those decisions for them. Okay, and this is this is also called as a surrogate decision maker. So you have to, whatever you do, you don't manipulate people. Even in case of medical processes, when you go to a doctor, you have a right to refuse whatever procedure you are going through, till the time you are conscious, you are even there are incidents or stories where the person is being taken towards the operation theater and he decides in between that no, I don't want to get operated. So he still has that autonomy to make that call until the time that the event happens. He has the autonomy to understand what is good and what is not so good for him in that procedure. He can take opinions of multiple doctors, etc., but the deciding authority is the patient itself, provided he has the capacity to take independent decision. Otherwise, there is going to be a surrogate decision maker in that case. So that's the principle of autonomy, which also applies to AI, at least principally. And the last one is we already spoke about it a lot. It's called the explainability. AI needs to be explainable, no questions about that. It needs to be transparent. It needs to be accountable. and hence it needs to be explainable. So there are a lot of people making important decisions for people, whether it is about the welfare schemes, about whether it is about the credit worthiness, whether it is about a lot of things which will impact human lives. And if they are using some kind of an AI model, even though there is a human sitting there who takes the accountability of that decision, that person needs to understand that how the models behave, how the models have decided whatever they have decided. So we have spoken a lot about explainability, interpretability and things like that, but yeah, models have to be transparent, they have to be explainable, and that's the reason that a lot of people, especially in financial sector and in healthcare, people prefer to use the simpler methods or models like decision trees and random forest rather than the neural network, LLMs, etc., because those are very, very hard to explain. Now this explainability can happen at multiple places. There is local explainability, then there is your there is global explainability, and then there can be your model specific or model explainability. The difference between them is that local explainability means that if the model has given a decision that Praval will not get his loan, or Praval can only get a loan of say 1 crore, not more than that, there needs to be some kind of an explanation given by the machine, by the robot, by the model, that why that particular decision has been made in this particular instance. Okay, so for an instance. In case of a global explainability, this talks about whatever automation or method that we have used. It tries to put that rational and say that this is how the model is going to behave, this is what parameters it's going to consider, this is how this is and if it is using a mix of models, or there is a model called as MOE, which is very, very popular these days, which is called as mixture of experts. So you have a variety of models and then you select which model to be used. So all of that rational is explained in global explainability, and model specific explainability is more specific to a particular model M, that this is how this model behaves. There can be direct interpretation, which is in case of models like decision trees or other place or the other simpler models, and there can be indirect interpretation, which is more of reverse engineering them and talking about how the models make decisions that they do, and that's more in the case of neural networks. We already spoke about SHAP and LIME and those kinds of things in the previous video, so I'm not going to repeat that. So that are the 5 principles of AI ethics. And this brings us to the end of this reading, and we'll touch upon the other things in the next section. Thank you. Okay, so let's continue module 4 itself, and today let's talk about bias, fairness and discrimination, more from the ethical standpoint. So we have spoken about most of these things earlier also in module 2, in module 3 as well, but let's focus more on the ethical point of view, so we understand that just for putting everybody on the same page, that what is a bias. Bias is a systemic deviation from what is actually expected. Okay, so that's the bias when your algorithm tries to or tends to systemically deviate, or we can also say that bias is a deviation from standard. Okay, so that's how we define the bias, and not all biases are ethically wrong. Okay, so I'll not say that not, and we'll talk about this in slightly more detail, but not all kinds of biases might be ethically wrong. Okay. For example, if you tend to create an algorithm which gives the possibility or the probability of a person being criminal or not. Okay, so this is your algorithm, and if you look at the past records, criminal history, you will say that the possibility of a random guy X being a criminal, if he is a male, is going to be much higher than that of a female. Okay, for some random person. So which mathematically is biased, because you are saying that guys are more miscreants or criminal in nature than women. But that's how the genetics and the behavior of men and women are there. So men tends to be more violent, men tends to be have a more violent streak, etc. So not all biases might be ethically wrong, and we'll talk about it. And let's start with the ethical reasons or ethical biases sources. Okay, so we spoke about a similar philosophy in the last lecture, or last to last lecture, where we were saying that how can some of these problems arise in different phases of the software development life cycle, right from requirements to development to testing, etc. So similarly, we'll see that how can the biases get into your final product or final model, right from when you are defining the problem specs. Okay, so in the problem specification phase, let's call this number 1. Actually, the problem is that when you have some goals, it is hard to define them, especially mathematically or using some kind of a metric. So if the definition of goals itself inherently carries some kind of a bias, then that itself can be the first phase or first problem, ethical problem of getting the bias into your enterprise ecosystem. For example, if there is a bank and it says that I want to, the goal is that minimize lending risk. Okay, which is a kind of a fair goal for a bank, especially if the bank is new and it is trying to get into the lending zone. It doesn't want to have a lot of NPAs, so it is saying that we will give loans only to people in the Indian context. If your CIBIL score is say 850 or more, I will give loans to only those individuals. But then this is going to create a bias that only the affluent will get the loans. Okay, and people who come from not so affluent families, people who come from socially unprivileged classes, or people who come from rural background, etc., who do not have the CIBIL score of 850 or so, they will not get the loans. So this goal in itself, while it might be the choice of the enterprise, but this is an ethical problem in the definition of goal itself. Then another example could be that if there is a hospital, and the hospital maybe it's a government hospital, and there are maybe 10,000 patients that come every day. In a country like India, if I have to give an example, so there is this hospital in Mumbai, which is the Tata Cancer Research Institute, where there are 10,000 people who come there every day. Now if you start prioritizing these people based on their medical history, okay, medical history, maybe their genetics. So when I say genetics, if they have some kind of documentation that this is how their parents, their grandparents, their siblings, etc., have been specially prone to cancers, etc., etc. If you use all of this to give the priority of these to these people, because you want to use your best doctors or resources to spend time on those which are which are very hard cases, or which have the cancers in the last stage, or which can be treated. So now this can also create some kind of a bias, because only on again it is going to be only the rich people will have all these tests. So all the poor people who accidentally came to know that some individual has cancer, or is suffering from a life-threatening disease, they may not have this medical history, and that in itself can create bias with respect to the goal that the hospital had intended to use. So that's the first category, which we were saying that in the problem specification itself. The second is of course the biggest is the data. Okay, so the data which we use for most of our algorithms, because your algorithm is as good or as bad as the data in itself. So if your data is not the right representative, if it is not clean, if it is not if it carries some misinformation in itself, then that is going to get into your algorithm, and when you deploy the algorithm, it is going to create a lot of problem. So data is also very important. So within the data there can be multiple kinds of biases. So one is called as historical bias. Okay, so historical bias, as the name suggests, it says that if you have a lot of historical data, and if you look at this historical data, and let's suppose again it's a lending issue, and if you look at the last say 30 years of data in a bank, and you look at what were the good loans, and what kind of customer profile or behavior was there where the loans were good and the bank was able to recover all the money. Now it will say that maybe maximum or the majority of these people are going to be men, because historically it has been very recently that women have been given those kinds of opportunities where they can go out and ask for loans individually, or as a individual applicant. So this means that the men are more likely to get the loans. So that's the historical bias. There can be another example. If you want to look at let's suppose the utilization of some kind of a public transport, and if you take data for say 2020, plus minus few years, you will see that this is a COVID time, and the behavior of people in this COVID duration was not like how it should be, before and after the COVID. So this kind of historical data can also give you some patterns which are not supposed to be there. So because of a particular catastrophic or because of a particular reason, the behavior of the people changed, and if you integrate this kind of a data, it is going to give you a very biased outlook. Okay, that people tend to travel less, or people sit at home. So that's the historical bias. The second kind of bias with respect to data is called the selective labeling. So selective labeling means that when you have a data and you selectively ignore some of its data. Okay, again, in case of loans, most banks analyze those loans which were approved and which were granted. So they don't look at those loans which were not approved or not granted. Okay, so their analysis of how good or bad the loans were is only dependent upon those loans which were granted and which were approved, which is fair also, because they will not have a lot of data around it, but then it's a kind of a selective labeling. Another example I can give you is in a lot of consulting firms, IT companies or other kinds of consulting firms, you will see that you have employees and you have also subcons. subcontractors. Now most of the companies tracks employee data. They will not track subcon data because they are not responsible for their career and other kinds of thing. Ideally subcons are supposed to be contractual staff which can be hired or fired at any point of time. But if they want to look at the employee satisfaction, or look at the attrition, or look at other kinds of employee experience, ideally they should take it from both these places, but they selectively ignore this and they only take this. So this is also kind of a bias, which we'll say is kind of a selective labeling bias. Then within the data itself, another kind of bias that we can talk about is sampling bias. So ideally the data that you use for your analysis, the data that you use for your analysis should be the true representative of the population that you are trying to study. Especially, let's suppose when people start talking about these opinion polls and people start taking into consideration how when the elections happen and before the results are announced, they tend to talk to a group of people, and then they tend to say that this is how the pulse of the people is on the ground. So most of the times those predictions fail because their sampling is not the true representative of the people who have come out and voted, especially in a country like India, where you have so many personas of people, urban, rural. Within urban also there are people who are rich, people who are not so rich, and middle class, and then people who are socially backward, etc., etc. So that is the reason that your sampling decides a lot on how your final response is going to be, your final accuracy is going to be, or how your data is kind of biased with the sampling that you have done. Okay. So I think that talks about some of these things that we were talking today. Then the next, after you have your data, so after you have your data thing clear, then the next is with respect to modeling, with respect to validation, and with respect to probably say testing, etc. So in this phase of modeling and validation and design and testing, in this case also there can be a different kind of a bias. It can be an algorithmic bias and those kinds of bias that can trigger in. For example, in case of LLMs, or in case of I don't know if you have heard about RAG kind of applications, where what happens, it's a kind of a chatbot that a lot of companies deploy, where you have a large inventory of articles, and then then the users tend to do a Q&A, question and answer, on that inventory of articles. So in the LLMs, when there is a question queue, and let's suppose it goes to an LLM, then after it goes to say a storehouse of knowledge, it will give the top 5 or top 10, or let's suppose top n chunks or top 10 pieces of information where the answer can be, and then these top n is processed, and then after this processing is done, the final answer is given. Okay, so now if there is a bias in getting these top 5 or top 10, that itself can be kind of an kind of a popularity bias, or even in Google, if there is a output, or if there is a website that it recommends, and if that recommendation is coming out by some kind of a mathematical formulation, or these days Google also tends to prefer those sites which enroll for their ads. So the top 5 or the first 5 or the first 10 responses are not going to be unbiased, and then it keeps on circulating. It's called the cycle of popularity. Okay, so something which is popular tends to be clicked more often, and then it actually becomes popular, and then it goes into the ecosystem, and the websites which are not so popular will get lost in the World Wide Web. And also in case of this Q&A system which I was talking, if there are some chunks which are for some reason not picked as top 5, will always remain hidden. So that those are some of the problems that can happen in ethical problems that can happen in the face of modeling. Then in case of deployment, so this time we are more concerned about the ethical biases that can arise in various phases in a software development life cycle. So in case of deployment, what happens that a lot of algorithms are still in R&D phase. Okay, so let's address the elephant in the room. Then there are a lot of LLMs, and these LLMs they come with some kind of a disclaimer that LLMs can hallucinate, LLMs can give you some kind of a misinformation, and they are a mathematical model, so they cannot always be right. So it will say that while I am trying to give you a response based on the best of my knowledge, but there are problems of hallucinations, etc., etc. So take this advice with a pinch of salt, and you keep the human in the loop. Okay, but what really happens is when your human in the loop, or the person, whether it's a loan officer in the bank or anybody else for that matter, or some kind of a jurisdiction, if there is a clerk who is trying to give some kind of auditing on the behavior of an individual, etc., etc., they will tend to get influenced by what is coming out of an algorithm, and they will probably not read these warnings so carefully. There is some kind of an automation bias that people tend to get, and they for a person to make a decision against what is recommended by the algorithm, only very, very headstrong and very, very strong people will do that. Otherwise, majority of people are going to probably go with what is recommended by the algorithm, which might not always be correct. So those are the problems, or ethical problems, and which can be biased, because the algorithm in itself is saying that I can hallucinate and misinform, and I can give you a biased output, but the person is anyway going to take that biased output. Okay, so that's on the deployment side. Now so that's the end of the software development phases on how bias can get into the ecosystem. But we also want to understand that between the bias and discrimination, they are not analogous to each other. Okay, so while people use these terms interchangeably, but not always bias and discrimination are analogous to each other. So when does bias become discrimination is that when you try to favor an individual or a group based on race, based on gender, based on age, based on ethnicity, based on country, or any of these parameters which are legally in some jurisdictions there will be legal implications of if you use these parameters directly or indirectly. So when the bias favors some of these parameters, it becomes a discrimination, otherwise not. So in some scenarios bias can trigger discrimination, sometimes it is not. And then about being fairness. So generally if you ask, fairness means absence of bias. Okay, so if the bias is absent, then it means that the algorithm or the process is fair. So fairness means, or fairness an algorithm to be fair means that it doesn't have a bias. And we have already spoken about fairness, possibly in module 3, reading first few readings, that fairness can be individual fairness and fairness can be group fairness. Okay, and it is mathematically impossible to build an algorithm which is fair at an individual level and at a group level, especially because base rates among various groups are not always the same. Most of the times they are not the same. In the US, between say blacks and whites, you will see the whites will have a better credit score than the blacks. In India also, if you look at some of the rural people, they may not have so much of bank balance and so much of financial prosperity as compared to some of their urban counterparts. So since the various groups will have different base rates, achieving group fairness as well as individual fairness together is almost impossible. Okay, so that's what I wanted to tell, was that this is how bias, discrimination and fairness are related with each other, but not they don't mean the same thing. Okay, so now the next thing is I think as per GARP, let me see, the next reading is around how do we avoid, or how do we mitigate these biases. Okay, so what are some of the mitigation principles, or how do we mitigate biases ethically? So as we said that it might be impossible to build a system which has zero bias, but there are things that we can possibly understand and take decisions which are in a larger perspective good for humanity. For example, in case of say self-driving cars, and there has been very few incidents where these self-driving cars have hit people and people have lost lives. So if we say that let these self-driving cars, when they are consuming this kind of a video input, and based on the video it is making some decisions, let's say we put some kind of a trigger here, and then say if it is an old person, or if it is a kid, or if there is somebody on the wheelchair, then let the decisions become more sensitive. So which itself means that if we make this kind of a decision, this would mean that people who are healthy adults, they'll become more prone, or they will carry more risk. Okay, because you have decided, or there is a decision that we have taken, that we will be more considerate to one group of people. So these are some kinds of decisions that the architects or the leadership needs to take, where things can be decided, that what is more prior and what is going to help in the larger scheme of things, from their business perspective, from their reputation perspective, etc. There can be technology solutions to mitigate some of these ethical biases, but then there is a thumb rule that I read somewhere that AI cannot, if you create an technology solution which can catch the bias and fix it, but it says that AI can't fix a problem that it created in the first place. Okay, so the bias itself is being created by the algorithm, if it was so smart that it could catch it and fix it, it would have not created the problem in the first place. But having said that, there are bias reports which are created by some auditors, and which are created by a group of professionals, and you can read these bias reports if you are using some kind of a, say, third party AI algorithm, or if you are creating some kind of an in-house algorithm. You can also get that algorithm tested or audited by these group of professionals, which are going to give you some kind of a bias report, and based on what comes out in those bias reports, you can decide whether you would really want to deploy it to production or not. The second is, on the data quality, there needs to be a lot of stress to be provided on the data quality. As I've been telling time and again, that the output of an algorithm or output of your model depends upon how good or bad your data has been. So if your data is diverse, true representation of the population that you want to work with, if your data is updated, it is not stale, if it is accurate, if it is true representative, if your data is free from past prejudices. Okay, if all of this is there, then your data is good. But it's just a wish list. You may not always have these things. And one more thing is that avoid synthetic data. What is synthetic data? Synthetic data is data that is created from the thin air, that is created not by real humans going door to door and getting information from real human subjects, but it is created from past. So sometimes it multiplies all the biases that are already present in your old data. So avoid building synthetic data. And if your data is good, then you are good. Your ethical problems will not happen. If your data has prejudices and old problems or historical biases, then you'll carry all of those things. The second is, it is very difficult but very important to have an auditing mechanism in your in your ecosystem, in your enterprise, so that whatever you do, whether you are doing auditing via tools or whether it is done with humans, but each algorithm, each application that uses AI needs to go through a set of assessments, and only after those assessments are finished, it needs to go into production. So auditing is very, very important. I've seen that most of the companies already have ethical committees. So ethical committees, what they do is they talk about the trade-offs. These days it is almost impossible for a company to say that I am not going to use AI, because otherwise it's going to become operationally very, very non-competitive. But they need to understand the trade-offs. So ethical committees talks about trade-offs. Ethical also committees talks about risks that come with all these AI algorithms, and it decides whether it is worthy to take that risk for the efficiency, for the competitiveness, etc., or not take that risks. Okay. And last but not the least is training of C-suite people. See, all these CXOs, whether it's the CEO or CDO or CTO will always most of the time understand all these problems, but the rest of the team may not be. They may know on a very high level that AI will inherently come with some risk, but they need to be appraised on all the business operations that the company conducts, and how much of AI is integrated, and what kind of the risks are there which inherently come because of these AI algorithms, and what are some of the consequences it can get into. So needs to be a training to C-suite people, telling them that There are the company has decided that it will use AI for modernizing some of their traditional business processes for efficiency and other things, but there are some risks that come integrated with it. So those are some of the things that the people need to understand. So that's the mitigation principles. I think we'll take a pause here. There will be some minor things that will come after this, and then that will be end of module 4. And module 5 I'll just briefly talk. I'll not get into details, but because it's all theory and nothing to explain. Thank you.